and welcome to this episode of Reliability 101 and 201 series by Texas RE. I am Evan Shivo. I work in the Reliability Assessment Services team of Texas RE as a senior engineer. Today, I will go over the various types of reliability assessments we perform at Texas RE. But first, I want to highlight our policy against antitrust violations. Please take a moment to go over this information. You can also find this information on our website. Should you have any questions, please reach out to Texas RE's General Counsel. Our work on reliability assessments is very purpose-driven. In performing these assessments, we focus on the data from member entities. We trend the growth of electric generation, demand, and transmission data. We gather insights and look for Texas RE regional risks in the areas of resource and transmission adequacy. Our engineering analysis helps us validate and build on our findings. We prepare our assessments and work with NERC to publish them. These assessments add tremendous value to our members. They review our key findings and become more aware of the current and future risks to the Texas electric grid. In the following slides, I will provide an overview of the work that goes into preparing the reliability assessments by the Texas RE Reliability Services team. I will first show you some examples of the previous reliability assessments. Then we'll discuss more about their purpose, process steps, and timeline. Let's briefly touch on each of these types of reliability assessments. Our seasonal reliability assessments are done ahead of summer and winter. Then we perform the post-summer and post-winter analysis to study on how the bulk power system performed compared to the assessments which we prepared. Our long-term reliability assessments focus on the distant future. The 10-year outlook uses a deterministic analysis. Within the 10-year stretch, we focus on the second and the fourth year for our probabilistic analysis. We report on the findings from both our deterministic and probabilistic analysis in our long-term reliability assessment. I will also go over the energy assessments, which we hope to perform starting in 2026. To get ready, we are performing a pilot study by working with NERC and the other regions currently. The goal is to come up with a process that we can implement next year. I would like to point out a few things before we move on to the next slide. It is important to note that our summer, our winter, and our long-term assessments are done in connection with the NERC assessments. In performing all of our assessments, we work with the Electric Reliability Council of Texas, in short, ERCOT. As we're aware, ERCOT operates our electric system in the state of Texas. There are additional assessments which ERCOT performs, and they are not part of these assessments that we'll discuss today. You can learn more about the ERCOT assessments by visiting their website, ercot.com. Here's an example of the NERC and Texas RE summer reliability assessments. The figure to the left shows the front page of the 2024 NERC Summer Reliability Assessment. Inside the 2024 NERC Summer Reliability Assessment, you will also find the Texas RE Summer Reliability Assessment, which is pictured to the right. Also, at the bottom left, there's a look at our presentation to the NERC Reliability Assessment Subcommittee. The presentation captures our analysis on how the summer went compared to what we projected in our assessment. Next, here's an example of NERC and Texas RE winter reliability assessments. The figure to the left shows the front page of the 2024 NERC Winter Reliability Assessment. Inside the 2024 NERC Winter Reliability Assessment, you will also find the Texas RE's Winter Reliability Assessment, which is pictured to the right. Note that the winter months in the report stretch from November through February, and therefore we call it 2024 to 2025 Winter Reliability Assessment. Also at the bottom left, there's a look at our presentation on a winter storm event to our stakeholders. This presentation captured our analysis on the performance of our electric system during the winter storm Kingston and the takeaways from it. Here's an example of the NARC and Texas RE long-term reliability assessments. This figure to the left is the front page of the 2024 NARC long-term reliability assessment. The years of the assessment are from 2025 through 2034. Inside the 2024 long-term reliability assessment, you will see the Texas RE's long-term reliability assessment as well. The remaining three figures in this slide show Texas RE's assessment for the 10-year period. As we go through the upcoming slides of this presentation, we'll have more opportunities to dive deeper into the Texas RE's assessment pages of the report. Now, reliability assessments are an important tool to gauge how the system would behave in the near and long-term future, which is very important for our system operators. This information can be very helpful for our policymakers as well. NARC has delegated this responsibility to perform reliability assessments to the regions. Under the rules and procedures, NARC has laid out the foundational requirements in these three bullets. First, identify, analyze, and project trends in electric customer demand, supply, and transmission, and their impacts on bulk power system reliability. Second, review, analyze, assess, and report on the existing and planned electric generation and transmission reliability of the bulk power system, including the reliability issues. Third, investigate, assess, and report on the potential impacts of new and evolving electricity market practices, new or proposed regulatory procedures, and legislation. Let's take a look at the reliability assessment. Let's define what that is. A reliability assessment analyzes and assesses the reliability of the bulk power system ahead of the assessment period. The assessment depends on the data from the entities which Texas RE collects by collaborating with ERCOT. This data set includes a projection of demand and generation, power transfers within as well as in and out of the system, transmission and generation outages, planned generation retirements, and upcoming resource additions to the system. There's a level of generation which we need to ensure for the projected demand of the system. This is called a reference margin level. You can see in the image that maintaining a good balance between demand and generation is important for our system operation. By analyzing the system ahead of time with respect to a reference margin level, we help our system operators make sure that the system can maintain a balance between demand and generation. A reliability assessment may focus on a season, such as summer or winter, or it may focus on the future, such as a 10-year planning horizon. A reliability assessment also looks at the transmission system adequacy and discusses key issues and trends that could affect grid reliability. Now, this type of assessment can be called a deterministic reliability assessment. This is because the data used in this analysis does not consider its variability due to system behaviors with respect to time. What this means is that this type of assessment does not consider a probability-based analysis. Now, this brings us to our next topic of discussion, which is a probabilistic assessment. What is that? A probabilistic assessment is still a form of reliability assessment. The goal is still the same, except that a probabilistic analysis describes events in terms of how probable they are at different times. The main idea is to apply how the electric system behaved historically in various extreme weather patterns and outage conditions in a reliability assessment of the future of the system. This means that we want to focus more heavily on specific times when the system might be stressed in terms of generation and transmission adequacy. The assessment requires input of system performance, such as generator outage rates, resource realizations in terms of energy produced, load characteristics, transmission congestion, and constraints. As you can see from the images, a probabilistic analysis of the system indicates trends in risks to the reliability of the system for any hour of the year. Therefore, it provides a trigger for further investigation that may be needed. This provides very helpful insights on system risks during various times of the year for stakeholders such as system operators. Therefore, a probabilistic assessment provides a more thorough overview of system reliability than a deterministic assessment. In this slide, we'll dive deeper as we compare a deterministic reliability assessment and a probabilistic reliability assessment of the bulk power system using some very key metrics. The pictures shown in this slide are also some of the pictures that you saw in earlier slides. At the top of this slide, we're introducing a key metric which we use in determination of system resource adequacy in a deterministic reliability assessment. This is called a reserve margin. A reserve margin compares the level of power generation with the amount of customer load in the system. It is calculated by subtracting the amount of megawatt demand from resource capacity, then dividing that number by the megawatt demand. In the top table, we show the projected megawatt demand as well as the projected megawatt generating capacity for the Texas area grid for the next 10 years to come up with the reserve margins. Again, this is from the 2024 Long-Term Reliability Assessment Report. We compare the reserve margins against a threshold value, which is known as reference margin level. We introduced the reference margin level in the earlier slide already. This reference reserve or reference margin level is established by ERCOT because they operate our system in Texas, and they have this very specific resource adequacy study which helps them determine the reference margin level. Considering the customer load is higher during the summer months, we're studying the summer values in this particular table in the 2024 NERC Long-Term Reliability Assessment. This table shows that the capacity reserves are higher than the reference margin level of 13.75% for all 10 years. This is also shown in the graphic next to the table. Now, let's discuss the probabilistic assessment by focusing on a very key metric called expected unserved energy, in short, EUE. This term means that at any given time, the system may not be able to provide that much energy due to demand exceeding available generating capacity at that time. In the bottom table, we're showing that in the 2026 summer and 2026 winter, you can expect as much as 10 gigawatt hours of load, which can be left unserved. Now, let's focus on the bottom figures in this slide. When you look at a 2-day period in winter, the extent of unserved energy could stretch from the evening hours into the morning hours of the next day. On a summer day, we could have unserved energy during the evening hours. Now, this is all based on probabilistic analysis that we performed, which went into the 2024 Long-Term Reliability Assessment, like we spoke about it in the previous slide. With the consistent growth of renewable resources, such as wind and solar, we're also depending very heavily on the charging of batteries when there's an excess of battery or excess of energy in the grid. And we discharge them when we need power, which is usually when the sun is not shining and the wind is not blowing. Therefore, the probabilistic assessment is painting a good picture here of what hours of the day we can expect to see shortage of power generation due to our heavy reliance of renewable resources. Again, the keyword is probability. As we mentioned in the previous slide, the analysis uses historical data such as extreme weather and generation outages, to name a few, in predicting the worst case scenarios during all hours of the year of the study. So in this example, in the year 2026, the winter and summer months were showing the EUE probability based on the data we had at the time. Now you can see that even though the deterministic nature of the long-term reliability assessment tells us that we have enough reserves for the next 10 years, we found out more details regarding uncertainties in our ability to serve customer load through our probabilistic analysis. Again, both of the deterministic and the probabilistic assessments for the future years are included in our long-term reliability assessment report. Now, let's look at our overall process steps for these assessments at a very high level. Generally, the process starts with an initial request for performing the specific assessment. This is usually done by NERC, which officially kicks off the respective process. Texas RE complies with the request. The first step is data collection. Texas RE staff works with ERCOT staff to initiate the data collection process. Once the data collection is completed, both staff work together to validate the data, which is utilized in various analysis and study processes, depending on the purpose of the assessment. As a result of the analysis, a variety of dashboards get created, and they also go through a review process. The regions get involved as part of the review of the dashboards and data trends, which is known as a peer review process. NERC works with the regions to collect final assessments, which are done independently by the regions. This is also where Texas RE staff would work with ERCOT staff to ensure correctness and completeness of the final narratives, which essentially is a summary of the overall assessments of the Texas RE region. All assessments are included in a draft report, which goes through a review process before the report is made public by NERC. Now, this slide specifically talks about the collaboration efforts between Texas RE, ERCOT, and NERC in completing the respective process steps. As we discussed, NERC kicks off the reliability assessment process each year with a request to the regions. Texas RE then works with ERCOT to collect and validate data necessary for the assessments. Texas RE works with ERCOT to perform required analysis, prepares the narratives and overall assessments of the Texas RE reliability. Now, Texas RE then provides its regional outlook and its self-assessments in the NERC publications. Now, here's an example process timeline for each of the assessments, which we have discussed so far. Note that these timelines could change as NERC and the regions find necessary. The long-term reliability assessments take longer to complete than the seasonal assessments. That is because the data and analysis that feed into the long-term reliability assessments focus on multiple years, and there are longer review periods for the process steps. The seasonal assessments, on the other hand, use a more condensed timeline because they need more up-to-date information and must be completed ahead of the seasons. The post-seasonal assessments rely on actual data from the system operation, and they also follow a condensed timeline so that the information sharing is more effective and timelier. In the next few slides, we'll briefly go over each of the assessments. Let's talk about the long-term reliability assessment first. The main purpose of our long-term reliability assessment is to review, analyze, assess, and report on the planned electric generation and transmission reliability of our electric grid for the future years, 1 through 10. Our data collection starts as early as the end of the first quarter. As we compile the data, we trend them and perform further analysis. We identify, assess, and report on areas of concern. We create dashboards and narratives to highlight these concerns in our report. We investigate, assess, and report on the potential impacts of new and evolving electricity market practices, regulatory procedures, and legislation. Now, during the preparation of our analysis, dashboards, and the overall report, we work with ERCOT and the regions to help with the review and feedback. We report on the findings. We highlight risks and lessons learned in our presentations to various stakeholders. One thing to note here is that the long-term reliability assessment timeline and process steps are changing. Going forward, the NERC public report is projected to come out in February. This allows more analysis work from the regions, such as energy assessments, which we'll cover in just a little bit, and interregional power transfer capability study, which is also included in the energy assessments, which we'll talk about in just a little bit. Now, as we discussed before, the probabilistic assessment is built on a probability-based analysis for the future years 2 and 4 out of the 10 years of the long-term reliability assessment window. The probabilistic analysis requires a very specific set of data. The data collection starts in the second quarter. Once we have the data, we perform our probabilistic assessment. We trend the data from our analysis and create dashboards with hourly risk insight. We incorporate our findings and we summarize them into the annual long-term reliability assessment report. Finally, we report on our findings, highlight risks and lessons learned in our presentations to various stakeholders. Prior to each summer, we prepare our summer reliability assessments. Here we identify, assess, and report on the areas of concern for summer operation. Once summer is over, we perform a post-summer analysis where we focus on the system behavior and ERCOT system operation, especially during extreme summer events. We compare that to our summer assessments. We report our findings, highlight risks, and lessons learned to various stakeholders. Knowing how our assessments compared to the extreme summer conditions help us identify improvement opportunities in the areas of data reporting and analysis toward the next assessment. Now, similarly, prior to each winter, we prepare our winter reliability assessments. Here we identify, assess, and report on the areas of concern for winter operation. Once the winter is over, we perform a post-winter analysis where we focus on the system behavior and ERCOT system operation, especially during extreme winter events. We compare that to our winter assessments. We report our findings, highlight risks and lessons learned to our various stakeholders. Again, knowing how our assessments compare to the extreme weather conditions, it'll help us identify improvement opportunities and improve our next assessment. Now, Texas RE will perform another assessment starting next year. It's called an energy assessment. This analysis includes the following. We will focus on a future year for a wide area energy reliability study. We will study whether our resources can meet our demand and operating reserves during all hours of that particular year. We'll work with NERC and ERCOT to perform this work. The planning areas within a particular interconnection will perform a transmission analysis to see if they can help their neighbors by transferring power during stress conditions. However, Texas RE will not perform this particular transmission analysis as part of the energy assessment because we are not tied to the eastern or western interconnection using alternating current ties, in short, AC ties. Now, we're currently working with NERC in a pilot study. Once the study is complete, we will have a well-defined process, and we will implement that process in 2026 for our first year of energy assessment. Now, it is important to note that Texas RE also prepares a regional reliability, performance, and risk assessment report every year for our members. Now, in this particular effort, our reliability assessment of the grid plays an important role. This particular report focuses on reliability performance of the bulk power system. The analysis and key areas of risks covered in the risk report include the following: grid transformation, resource adequacy and performance, bulk power system planning, protection and control systems, situational awareness challenges, human performance, changing resource mix, resiliency to extreme events, cyber and physical security, and critical infrastructure interdependencies. For more information, please visit the Texas RE Reliability Services webpage. Now, let's summarize what we have learned in our presentation today. We work very closely with the staff from ERCOT and NERC in preparing and performing all of our assessments. After every seasonal assessment, we look back at summer and winter. We observe the system behaviors and learn more from the ERCOT system operations and the extreme events. The insights and lessons learned help us in identifying ways that we can improve our reliability assessments. As we know, our electric grid is evolving constantly. With this evolution, our electricity market practices, regulatory procedures, and legislation are also changing. We report on their impact on the adequacy and operating reliability of the bulk power system. Now, the focus of our electric reliability has shifted to energy assurance over time. We should not look at just the system capacity, but also look at whether we have the supply of power when we need it. That is why Texas RE is working with NERC and ERCOT to prepare annual energy assessments starting in 2026, which will be in addition to the list of assessments which we already do. Now, that concludes my presentation today. If you have any questions, feel free to reach out to us in the Texas RE Reliability Services organization. We'd be happy to help you with any further information on our reliability assessments. Thank you and have a great day.